Good afternoon, and welcome to Upskilling for the Future, Engineering, Science, and Technology, a panel discussion. I am Woodrow Winchester III, Executive Director of Texas Engineering Executive Education, which we like to call TEXE, the professional development and continuing education arm of the McCombs School of Engineering. So just from a logistical sort of perspective, for today's webinar, we're planning to spend 30 to 40 minutes on discussion with our panelists. Listeners can submit questions via chat throughout the discussion, and we will answer as many of them as possible, both within the context of the discussion and also within the last 20 to 30 minutes of the prepared presentation of the webinar. So to get started, I'd like to introduce our esteemed panelists. Our first panelist is Dr. Suzanne Barber. Suzanne is a professor in the McCombs School of Engineering's Department of Computer and Electrical Engineering, the director of the Center for Identity, and the program director for the Master of Science in Information Security and Privacy, which is a joint offering of the School of Information and Center for Identity. Her current research investigates trusted digital identities, cybersecurity, and privacy. Welcome, Suzanne. Our next panelist is Dr. Eric Bickel. Eric is a professor in the McCombs School of Engineering and director of the Operations Research and Industrial Engineering Graduate Program and the Engineering Management Program. Eric's research interests include the theory and practice of decision analysis or decision-making under uncertainty and its application in the energy, climate change, and sports industries. Welcome, Eric.
Thank you.
Our next panelist is Dr. Greg Durrett. Greg is an assistant professor in UT Austin's Department of Computer Science, where he teaches in both the online Masters of Science in Computer Science and the online Masters of Science in Data Science program. His research is focused primarily in the field of natural language processing and improving techniques for assessing and reasoning about knowledge in text. Welcome, Greg.
Thanks, Woodrow. Great to be here.
Oh, awesome. Great to have all of you. So to get started, let's kind of set the table for today's discussion. So given how work has and is changing, given such trends as the increased prominence of emerging technologies, such as artificial intelligence, as both a component of work and doing work, the transformation of the workforce, more remote and virtual engagements, and the reinterpretation of career, which is very intriguing to me, with individuals switching jobs more frequently, contingent work, side hustles, etc. Can each of you talk about the current state of engineering, science, and tech careers from your individual perspectives? Greg, would you like to get us started?
Sure, yeah, I can get started. So I guess just to give a little bit of context, I teach both at the bachelor's, the master's, and the graduate PhD level. And primarily in computer science, people go into a few different kind of types of job titles, all broadly in the tech sector. I think software engineer is probably the one that people are most familiar with. There's also product manager roles, which is still a technical role, but in many cases a little bit more focused on users, how you actually kind of develop and design products as opposed to implementing them. And then there's kind of data science, data analytics, these sorts of things, which are, again, less about building big software systems, but more about kind of creating insights for companies and things like that. So those are kinds of things that we see people going into from computer science, from data science. Obviously, that kind of online program is designed to prepare people precisely for that role. And I think we expect to see that in our new Masters of Science in AI as well, which is launching fairly soon. I think all of these jobs, like you've probably read about them, they, are typically pretty well paying and fairly cushy. There's been a bit of a contraction in the tech sector over the last year. But that said, I still have PhD graduates who are signing offers for like 300K total compensation. So you can definitely still make very good money there. even if the free food is like a little bit less good than it was before. So, I mean, if you want to get a sense of like for your experience level or where you're at, kind of what sorts of things are available, levels.fyi is probably the main site that people go to that has this kind of information. There's a lot of support for kind of hybrid and remote work and these sorts of things. So, I mean, it's definitely that, all that said, it's definitely competitive, especially to get offers at sort of the the FANG companies. Obviously it's a very long road to get through the interviews and to actually land the jobs there. But there's a lot of stuff at other firms as well. So still a lot of opportunities in that sector. And I think we'll probably dive into it more further in the conversation. So I'll just kind of stop there.
Oh, appreciate that, Greg. Yeah, I was going to ask if you could drop in the link levels.fyi.
Yep.
And it's there. Thank you. Awesome.
Thank you. Yeah.
Eric.
Yeah, hopefully Greg will put in the link to where we can get these 300K. Wow, sounds great. So yeah, so like Greg, I teach at the undergraduate and graduate levels. At the graduate level, it's operations research and industrial engineering and engineering management. And there's a fair amount of, I guess, overlap in terms of the interests of those two groups, but within operations research and industrial engineering, it's primarily a focus on maybe decision making, making systems and processes better, with a lot of that driven by data now. And so analytics is, of course, a big focus of ours within the ORIE program. Most of the students, our particular program is probably half master's, half PhD. So we have a lot of students that just come in and get a master's degree. I think, like Greg's finding, very quickly employed in very attractive jobs. Within engineering management, that's a professional master's program. I would say there the big focus is project management. So these are people that have already some expertise. They've been working for a few years, maybe in high tech, but it could be in energy is another big draw for us. And they're now moving into a role where they're going to be managing other people, managing large scale projects. So those are the big areas for us, Woodrow.
Oh, nice. Thank you. Suzanne.
As was mentioned, I'm the director of the master's degree in information security and privacy. And at first look at that title, you might think that it's very technically focused, which there is a technical aspect to it as well. We designed the curriculum with a belief that a professional in this area needs to have an understanding of many different disciplines, the law that impacts information security and privacy, the public policy that impacts information security and privacy, the business governance, data governance, and just actually from a societal perspective, how do we view information about us and information that is critical to our organization. So having said that, what we see is professionals who may be in the fraud sectors of their organization, maybe in the products that have to hold data, that have to be secure and have to respect privacy. So really, it tends to be a topic that is pervasive in every organization, in every product, and increasingly so, right? Privacy was an afterthought before, now can be one of the primary factors in designing your systems. So I guess my 2 points is that one, pervasive across organizations, and that to be successful, and I think to be successful in moving up the ladder, you need to understand many different disciplines. So what happens is the tech person understands that they can't move their technology forward without understanding the public policy and the law governing it. The law folks and public policy realize they can't make effective policy without understanding the technology. How can you make effective policy if you don't understand how that AI algorithm works and might impact somebody's privacy. So these systems are requiring, I think, folks to upskill across disciplines that they may not have thought about before.
It truly the changing nature of work and work in this arena, and as you've articulated so well there, how in specific sort of disciplinary or professional, what used to be kind of silos really don't exist anymore, and actually the work that's required is truly interdisciplinary in nature, and really needing to know various different aspects and components of the system or the technology that you're developing and building per se, which really kind of does speaks to the criticality of the constant need for upskilling and reskilling to get those sorts of skills and competencies in order to contribute. Great and interesting point.
Because often as an undergraduate, we are educated in silos, right? And so I think there's an opportunity at the graduate level to expand those horizons for yourself. Yeah.
That's a really great point. And actually, I'm going to kind of use that and springboard a bit here, and it will allow the panelists to kind of talk about that a little bit. So if we could go a little deeper in terms of, some of your programs under your specific sorts of portfolios, and if you would kind of talk about those sorts of degrees of freedom and flexibility that are offered within those types of programs to give students the ability to pick up those sorts of skills and competencies, maybe not necessarily aligned or formally tied to a given degree program or certificate program.
Who do you want to go first?
Oh, Suzanne, if you would appreciate it. Yeah, thank
Sure.
you.
I guess there is two ways to have, maybe there's multiple ways to have flexibility. One is the curriculum and the courses offered, and the other is the modality, right? Those are the two things that I think of immediately. So for the master's degree in information security and privacy, you can attend in person or online. You have your choice. And in fact, in a given weekend, you can, one class weekend, you decide to attend in person, the next you can attend online. So your choice. I guess the other flexibility is schedule. So we don't require you to show up Monday, Wednesday, Friday. It is Friday, Saturday, once per month. Okay, so you have to take off a Friday once a month, and then ask your family for time on that Saturday once a month. So schedule and modality flexibility. And then for us, we have a 10 set of courses that are very multidisciplinary. There's business courses, there's technology courses, law, public policy. There's a information and society, which I've had many of a tech person say, what am I taking this for? And then exit the program saying it was the most valuable course that they took in the curriculum. But we have 10 courses that everyone needs to take at the end, a capstone, which you get to choose the topic you want to do your capstone about. We have plans of expanding our curriculum, but right now it is 10 courses that you take with your cohort that you enter with. So I guess we can talk about the value of education. And one of those often in these programs is not just learning from the instructors, but from your cohort. When you have professionals that are attending class with you, you develop a network of other professionals and executives that you will take beyond, as well as your education beyond graduation.
Great point, Suzanne. And I know, Eric, within the engineering management program that you direct, it is kind of that cohort model as well. And I've heard you even mention kind of the value associated, with the learning, in those cohorts, and people from different cohorts being comprised of people from different sorts of industries, disciplines, that sort of thing. And the cohort really kind of learning from each other in a more informal sort of basis as well, and getting insight and perspective around these differing sorts of things that are more industry or domain specific that may not come up in core class curriculum or discussion, but are explored, within the cohort in the context of group projects, capstone projects, and that sort of thing. Would you like to elaborate on that?
Yeah, sure. And these cohorts, the groups, they really become lifelong friends, I think, in a lot of cases, develop good relationships there. So yeah, the engineering management program, it is, I think, as Suzanne described, it's a professional master's program. It meets one weekend per month, usually a Friday, Saturday. A typical load would be students taking 2 courses in a semester. So you'd have one course in the morning on Friday, Saturday morning, 8 to 12, and then another course in the afternoon from 1 to 4. And then we also have 2 project courses, one being a capstone project. Those are typically completed in the summer. They don't have to be, but that's typical would be 2 courses each semester and then 1 project in the summertime. And with that cadence, you finish in 2 years. It is possible to finish in 15 months by taking additional courses during the semester. Some students take 4 courses. That's usually students that aren't working. The majority of the students are working at the same time. And in terms of modality, you can be in person or you can be remote synchronously. And it is really pretty seamless. There's students that are there in the classroom, there's students that are attending via an online system, and they're all participating together. Most courses, I think, have some type of group work, so there's a lot of opportunity to work with your cohort. We have courses in management, like managing people, managing organizations would be a primary area. There's some business foundations courses, marketing. There's a legal issues technology management course, finance and accounting. And then we have probably some more analytic decision-making focused courses. There's an analytics course. There's a decision-making course, which I teach, and an operations management course. So I think, like Suzanne, it's 10 courses and students follow a fixed program of work that'll get them done in 2 years.
Greg, I know your programs, the model is a little different. I don't think you have the cohort model per se in the context of the programs in your portfolio. Can you talk a little bit about your model of instruction for your programs, and also opportunities for students to get additional sort of training around maybe elective courses? Are there options for elective courses, or to take additional classes to kind of build expertise in a given sort of industry sector, such as energy or specific sort of application domain?
Yeah, so I guess I'm not exactly sure how the cohort models work for other folks, but like we do have admission every semester basically, and the courses, even though it's a fully online program, like the courses are asynchronous in the sense that like my courses, videos that you watch and then you do assignments, but like those assignments are due on like, October 15th, everyone has to submit it. And so you have to watch everything and done all the work up until then. So like there is still opportunity to collaborate with folks in the course, and we see a lot of that. And I think students in the course get a lot of benefit out of that. In terms of the curriculum itself, I think the link there kind of describes it. I will say that, this is not really a sort of boot camp or a like online certificate. Like we're really trying to go for a kind of rigorous, the courses that are being taught here are basically the same ones for the on-campus MS and PhD students. So like, you're going to learn machine learning and you're going to get the kind of rigorous introduction that the on-campus students get. And there are, some degrees of freedom in terms of electives in the curriculum, but like you do basically have to take the core computer science courses that are sort of expected for someone with a master's to have.
Awesome. Thank you for that. And when we talk about the specific sorts of, well, hot skills, that sort of thing in the tech and engineering and science arenas, already some have been mentioned in conversation: data analytics, machine learning, security that Suzanne kind of talked about. And these are pervasive and actually, becoming more important, across, different sorts of, job titles, professions. What are some other sort of hot skills or competencies that you all see kind of almost not just growing in prevalence across tech and engineering and science in general?
I guess maybe I'll jump in here first. I mean, I think, in tech, the sort of tools and skills that people are needing are always changing. I think one of the things we've seen over the last year has been the rise of like ChatGPT, GitHub Copilot, these kind of generative AI tools, particularly for things like GitHub Copilot. I think successful software engineers now are using this. Like if you're not using it, you're at a disadvantage. And it's also helpful to understand the kinds of these things that these tools can do and can't do, which is something that having a bit of a deeper understanding gives you. So I think that's one thing I would kind of call out there as a specific skill set.
Thanks, Greg. And Eric,
Okay, I could say just a little bit, and then if Suzanne wants to add to it. I think the ones you mentioned are certainly what's hot right now. I think in terms of the like core skills that are useful, I don't see those have really gone in or out of style. Like from an engineering perspective, like problem solving, right? I think is still what a lot of companies are looking for when we have boards, alumni come back and give advice on the program. Critical thinking skills, how to solve tough problems, how to communicate those things. I mean, that seems perennial, and a lot of I think fundamentally what we're teaching in engineering is just how to think and how to solve tough problems.
Suzanne, anything you'd like to add?
Yeah, well, and before I became the director of the master's degree in information security and privacy, I was the director of the software engineering master's degree program. And, one of the things I've seen when it comes to software is, can you code? That used to be something that was often a programming job, was often reserved for somebody with a degree, which that is not the case anymore. So then how do you differentiate yourself? And I think do you know how to build software that shows up on the mark, on time, and in budget? And that's a different ball game. Can you code? Can you build software with engineering discipline is another question. So that's my 2 cents about software engineering. But the other part of that is, and I hope I'm clear when I say it, is can you as a technical person not only speak the language of your profession, like whether it's, software engineering or electrical engineering or whatever, but can you speak the language of the business? And so can you translate the kind of things that you're doing as a technology contributor to how it contributes to the business? And more, I think, whether that is because you're an entrepreneur and that's what you have to do that, or because you're just trying to get your ideas noticed and promoted within the organization. So, and that then speaks to a lot of the skills that Eric was just talking about, in that can you communicate your ideas and evaluate them and think about them critically and all of those kinds of things. So, yep.
Yeah, really great insights there. As Eric stated, and as you just echoed there, Suzanne, it's like the fundamentals really truly don't change. But as Greg alluded to as well, in terms of just these newer sort of technologies or potential sort of models and methods which kind of enable that, so different tools and techniques that we can actually utilize to help us get better at doing those sorts of fundamentals, which often leads to kind of a conundrum for folk that are looking to upskill and kind of reskill. Where should you put kind of the focus on learning the technology, the tool, the fundamentals, and how do I know if, I've got the fundamentals down, and more for me would be, learning more around the different sorts of tools and techniques. And that would be the sort of program that I would be better or more appropriate for me versus something where I could get more of the, the fundamentals. So I would like to pose to the panel in terms of, making that sort of assessment, as someone looking at upskilling and reskilling, how do you assess kind of, what truly your needs are? And then really then exploring what possible programmatic pathway, because there are lots of pathways, which we've already kind of talked about, certificates, micro-credentials, degree programs that might be appropriate for you. So any guidance on kind of navigating this, understanding what you need in the context of what you are trying to achieve professionally, and then, kind of translating that into kind of some core set of, I'm kind of using software engineering here, core set of requirements.
Yeah, no, that's what I was thinking.
Kind of utilize in order to make the decision around an appropriate program.
Yeah, I could say just a little bit. I haven't thought about it exactly in the way that you're describing, Woodrow, and I should, but to me, it seems like if you're trying to get hired initially or transition or lateral, that you need to have expertise in what's currently needed from a technical content perspective, like machine learning, for example. But as you progress in your career, your advancement's going to have more to do with some of these more fundamental, I think, skills, critical thinking, communication, emotional IQ, and all those types of things, I think, are like what you need for the long haul. But getting in the door, I think companies have current problems and they need people to help solve those current problems. And so that's my thinking, just depending on where you are in your career, what you're trying to do, but the others may have better thoughts.
Well, I agree. And I'd say, and your first test of communication is, I was talking about selling your ideas, but your first test is, can you sell yourself? And can you communicate how, so knowing what that list of needs are is, what are organizations looking for and what are the skills that they need to, maybe Woodrow, the requirements, right? So matching up against those, because often you get filtered against those, right? And so you're gonna just not even get a conversation with anybody unless you can check some of those skill boxes. But yeah, I think the progression after that job has more to do with some of the other thing, or has as much to do, let's say, with some of those other skill sets.
Thank you for that, Suzanne. Greg, really, what your perspective?
Yeah, I mean, I guess I don't, I don't know how to do that sort of critical evaluation. I can tell you a little bit about the sort of the folks we see in like the data science program, for example. like, I think, you know, a kind of canonical type of person is like someone working in petroleum engineering who realizes they're kind of dealing with more and more data, but they don't have a sort of stats background, or they don't really understand the sorts of analyses that they're being asked to do at a deep enough level. Or similarly, someone working in data analytics, but they've come in there primarily through a software engineering path, and they realize they, again, want a more like solid statistical mathematical foundation. So I think this gets exactly to what Eric was saying, which is like, you know, if you really want to go far, you probably need that like strong foundation upon which to build. You know, you can't just be sort of using the kind of tools of the day that everyone else has access to. So yeah, I mean, like in terms of how you decide which of these paths you want to take, I mean, that I'm not really sure I can say a lot about, but yeah.
But there are resources that and to your point, but there are resources available probably from an advisement sort of perspective with your program that help students kind of, you know, navigate and understand what may be appropriate sort of pathways. And I'm sure, and that's kind of the case for all the panelists in terms of their specific programs, that there is that sort of support from an advisement sort of perspective, and helping students not only from advisement once they're in the program, but folk that are looking at and evaluating program to see if it does meet their needs, to kind of help them make that sort of decision making. And I know in some programs do have some tools and not techniques, but tools that are available for students to kind of help in that sort of decision making realm. Is there advisement sort of services offered?
It's certainly in engineering management, yes, right. And I often talk with students, and there's other resources within the you know, within the program there that can help with that. And of course, Cockrell School of Engineering has resources as well. But
Yeah, I think we have staff, you know, that will, we have info sessions very frequently, so people can, you know, ask those questions that are very specific to their own experience and the journey that they're looking to make. So, and I think that maybe if you wouldn't mind, I'll tack on to Claire's question in chat about, because I think we get this question a lot in those info sessions in career is, you know, what kind of people will be in my cohort, right? Or they're gonna be like me, or they're gonna be so different than me that we won't be able to share experiences. And so for information security and privacy, there are a number of people who are either they're in one career, they find that they're confronting a lot of these kind of challenges, and they find them interesting. And so they're using the degree to change career paths, you know, within their organization or across organizations, so that they are career change. Sometimes I call them retreaders, right? They're going to go through another. Some we used to only admit folks who had significant experience, and we found, and they had learned a lot about their profession through their experience, because their undergraduate degree was a long time ago. We also learned that there were a lot of people who were fresh out of college who knew a lot about the topic, more from a theoretical point of view, right? But and so we've started to mix some of that, not a lot. There's still more experience probably in the program than fresh start, but we have started to combine that with, I think, success to folks who have maybe more recent academic expertise to folks that have a more recent or a longer term professional experience. But and then again, I think a lot of times folks find themselves, let's say the engineer who and Eric, I shouldn't be in your lane, but you know, it's like, we didn't give them as an undergraduate all these project management skills, right? Or we didn't give them as an undergraduate all the information that they needed about information security and privacy. And then they find themselves in jobs that need this knowledge set. So it's just, born out of necessity sometimes.
Great point. And I know we're at the point where we're going to entertain some questions from participants, and it seems like questions are rolling in. And thank you, Suzanne, for fielding Claire's question. I'm going to shift over to Sunshine to kind of help me kind of triage the questions and pose the questions to the panelists. Sunshine?
Yeah, so we following on that theme of careers fresh out of college. We've got someone asking, if you're a new engineering graduate and you're looking for a position, how do you market yourself to get that first job and maybe more and prepare, let's see, and be more skilled in the job search? What's going to help you actually land the job?
I guess I can speak to this a little bit from the software CS perspective. I mean, I think, there's a lot of competition now. I think, having a degree from a good school is a great starting point. I think another thing that people want to see are the kind of practical skills. So, usually people try to curate a GitHub repository of their coding side projects and things like that, something you can show to employers to, show that this is the kind of thing I can build. And then, of course, you have to be able to pass the kind of technical aspects of the interviews and stuff like that. But I do think that basically, I do think that going even beyond what you kind of learn just in the curriculum and showing that you've done more learning on top of that, more building, taken more initiative yourself is one of the big differentiators.
Gotcha. And
I could just add, I think that's all great too. And then of course, getting work experience while you're an undergrad, internships and so on, I think is really important.
Experiential education. And just out of curiosity, do your programs include that in the curriculum, or how would you advise folks to get that experience while they're students?
So I'll continue and the others can add. Within engineering management, so this is a graduate program, students can one of their projects should be from their employer. If they're not working, then we have a course that lets them pursue an internship, and they can turn that into a course for credit. So at the graduate level, we encourage that. At the undergraduate level, I'm not as certain. I've helped students, I filled out lots of recommendations and so forth, but I think it's been a lot of their work, but I don't interact with at that level as much.
Okay. Ariel Sama is asking what advice you offer to someone who's very curious and wanting to build a technical career without sacrificing curiosity.
That is a great question.
I don't see why there's a need to sacrifice the curiosity at all. I think that, at least in like our MS programs and things like that, you get to learn a lot about a lot of different topics. And then I think that, again, if you're in software or something like that, you need to constantly be improving your skill set and learning new things. So I think that curiosity is actually like the main thing that will set you apart from someone who just learns out of the textbook and then doesn't really kind of refine their skills further. So yeah, and I think most careers do really kind of encourage that as well.
And I think that's one thing that we do a great job across, the entire portfolio of continuing and professional education programming at UT is fostering and just literally encompassing this notion of, continuous learning and building in our programming, the desire and ensuring that folks understand that lifelong learning is the future, and truly, in order to stay competitive. And that's one of the things that I was alluding to in one of the first questions, in terms of the nature of work today, and the nature of careers today as well, in terms of folks switching careers, changing, emerging sorts of technologies, and that sort of thing, as Greg alluded to. I mean, it's by default that you have to continue to learn and develop and grow, and these sorts of programs definitely kind of facilitate that and enable that, and are structured and designed to kind of support you even being able to build, your credentials, and then oftentimes kind of leveraging credential build to other different degree programs, stacking those into degrees potentially kind of exist as well.
It's funny that you asked the question also, because in part of our orientation, we talk about getting ready to go to graduate school, and that curiosity being kind of a prerequisite, that for folks who have been actually in the workforce for a long time, or doing the same job for some time, you get comfortable. And so in graduate school, you're going to be working on things, learning new things that might not always be just according to some formula. There might not be a buttoned up answer, right? In terms of 2 + 2 = 4. That really graduate school is about really exploration of a knowledge space, knowledge area, and being comfortable with that. And for information security and privacy, it's multidisciplinary. So the tech folks come in and they're probably very comfortable with the tech courses, and then may not have the same comfort level with the business or the public policy. So I think graduate school is a beautiful and wonderful place to explore curiosity. And then your career is about taking that and making it useful to somebody, because it turns out that curiosity, just for the sake of curiosity's sake, actually does not pay that well.
Right. And speaking of the other end, the employability and bringing these skills in, Leslie is asking how the pandemic impacted science and tech industry jobs. Did everyone have to pivot a little bit and add new skills, or was there just a growing demand for some existing tech skills?
I'll take that one a little bit, because I think that there has been a growing conscientiousness and awareness around the dangers and the need for information security and privacy, when so much of our, not that it wasn't there before, but I think it's been an increased need and attention that organizations, for a lot of different reasons, have had to pay attention to security and privacy, especially of personal data of individuals. So it's been a boom for our area and discipline.
Yeah, I don't know. I guess for sort of big tech stuff, like I said, we've seen a contraction in the last year. I think whether you can trace that economically back to the pandemic, I think is very complicated and would need some economists to help answer. I mean, I think that regardless, like, there's still a lot of hiring in both that sector, and then, like, other companies as well are still kind of gearing up in these directions. Like, I had a joint project at one point with Walmart, and that's not what you think of as a tech company, but they do have a labs division that I think is based out of Dallas. And, so they had a bunch of folks who are basically doing sort of R&D, software engineering type stuff. And because of the pandemic, probably, I think there is a bigger emphasis on virtual kind of automated things. And so we're probably seeing more companies in traditional sectors like paying attention to those sides of their business as well.
In engineering management, it was, how do you manage projects remotely, right? Large projects remotely, and work with dispersed teams. And that was that was a challenge, and where a lot of students' interest was going. A lot of our projects were focused on that, and that, I think that's continuing. I think that's still a need maybe it's lessened slightly, but I think it's going to continue.
Great. Well, Woodrow, we have reached the end of our questions. Everything has been answered.
Awesome. And we do have a little bit more time, so if folk have any additional questions, feel free to put those into chat. And what I'll offer as a final question, maybe could generate some additional questions from the participants as well. Just some words of thank you for that. Some words of advice in terms of just navigating this world of reskilling and upskilling, again, specifically kind of understanding what your specific sort of, when I say your, meaning from someone interested in and recognizing that there is a need to reskill or upskill in a particular area, how to do that relevant sort of kind of needs assessment to understand, what it is and what level needs to kind of be developed. And then, again, kind of translating that into some requirements to understand, what could be the appropriate, because as we've kind of discussed today, lots of different ways to kind of, to build and develop these sorts of skills. So what may be the appropriate sort of pathway for me? And in that regard, modality of program, we've already talked about some online programs and engineering management program kind of in person. So, that type, is it a full degree, certificate, or even some sort of micro credential? So making that sort of decision. So assisting in decision making around upskilling and reskilling.
A quick thought, just I think you want to make sure you're working on something you really enjoy. So I think if you can take a course or two or a certificate, and some programs you can combine certificates and stack them to get a degree. I think that kind of flexibility, at least if I was thinking about doing it or advising my kids or something, I think that would be useful. So you make sure you're really headed down a path that you want to go down.
And I think asking programs about the kind of people that are currently in their program and the kind of people who have graduated from their program and what they are doing now, and are those the kind of jobs that you're in, careers that you're interested in? Not that you couldn't be the first in another career in another job, not to say that, but just that can give you a familiarity about the kind of cohort that you might be going through the program with, or the alumni base that you're getting ready to join.
Yeah, I guess speaking a little more from the CS side of things, I think that one thing you will always need to do in your career is stay up to date with the latest tools and the latest framework. So if you're in a position where, let's say you're doing web front end stuff, and if you can pick up React and learn it and master it on your own, that's great. If you're not able to, or if you feel like, wow, there's like pieces of this that I really don't have the kind of fundamental understanding to be able to do that, then I think that's a kind of indication that you need that sort of more broad, maybe stronger foundation, and kind of suggest that sort of type of education you can get. So I think, like, especially in tech, there's a range of things from traditional degree programs to certificates to like reading someone's blog post, right? And like where on that hierarchy you need to fall is probably very person dependent, and depends on sort of how far you can, you can get on your own.
Great advice. Great advice. I think we did have another question come in, Sunshine.
Yes.
Okay.
Ariel says, is it not timely to encourage technical skills in entrepreneurship and reduce the risk of unemployment? Maybe
No, I was just going to say, I mean, I do think that, like, one of the things that in tech we're starting to see more of is like, it's less the idea that like the engineer is just locked in their like office, like writing code all day. I think the more of the kind of stack in terms of, upstream development to understanding what users want, and being able to market it and deploy it. If you have all those skills, you're in a better position to, let's say, start your own company or something like that. But even the more of that you can capture will make you more effective at your job, rather than just someone else has to translate the requirements and then you do exactly what they tell you because you don't understand them yourself. You want to be able to, be able to talk to customers and understand where those customers are coming from. So I would absolutely agree that that's a good other skill to supplement with.
I would say that my comment that I made earlier about that speaking the technical language as well as the business language came from my experience as leaving the university for a while and starting a business. And I was great at talking to fellow engineers and peer, and was not great, or thought I was great actually, but turned out I wasn't. I could improve a lot in terms of talking and translating ideas quickly, concisely, and in a language and a way that other people cared about. And I'll just also, so I think, and I continue to work on that, right? To be able to translate ideas to people who haven't spent the last 20 years thinking about it like I have. So, that's really important. And I will just say that, and I know this is like an obvious thing, but I just don't bury the lead in your resume either. I just can't believe how work on your resume, work on how you sell yourself and how you sell your skill sets. And I know that's like a dated comment, but I can't tell you how many resumes I look at that I say, wow, now that I've met you, I wouldn't have thought that was, your resume and you don't match. And so that is how you present yourself online, your professional branding and is important.
Great.
One last question. Are there any engineering and design crossover certificates available at UT Austin? This person, Lisa Grant, is interested in industrial design / product design. How can she address that?
Woodrow know more about that than.
Yeah, and that I love that question, because we're actually looking at developing some courses which could eventually lead to a certificate and possibly a graduate degree in industrial product design. It currently does not exist formally. One could possibly piece it together. And Lisa, I would love to talk to you more specifically around that and what we do have currently that you could take, because we have a very comprehensive, which is outside of my portfolio, but we have a Center for Integrated Design, and it's within the School of Design, which is housed within the College of I think Fine Arts, if I'm not mistaken. Assistant Dean Doreen Lorenzo is kind of over that programming. So I can definitely give you the associated contact information around what currently exists. And what we're looking at exploring is kind of in collaboration between design and engineering through our mechanical engineering program. So some great things exist. And we're actually kind of boosting our capacity and capability from a programmatic perspective in that regard currently. So some great things happening, yeah. Because we're really beginning to kind of see as we talk about kind of the future work, the nature of work. Again, this kind of alluded to with the panelists in their discussion and conversation, how things are more interdisciplinary, and really beginning to kind of see this more integration of, especially from a design and engineering sort of perspective, and really kind of speaking and responding to that from an educational perspective.
Great. So we've shared the design and creative technology.
Thank you, Sunshine, for that.
Yep, you bet. And you can learn about each of the programs represented by our panelists today. We appreciate everyone for the time.
This has been great. Thank you all so much.
All righty. Thank you.
Thank you all.
Bye-bye.
Thanks, everyone.